Hey guys, Mr. T here, just doing a quick video on how to connect the Vernier 25G accelerometer to your computer and use it with the Lite software, and also how to calibrate it and the idea of calibration. So you're going to be using this giant tangle of cables. Here is the Vernier 25G accelerometer, so accelerometer that can go up to 25 G, 25 times the acceleration due to gravity. So this is the business end here. This is the accelerometer part of it. And so you'll see that long arrow there that indicates the direction of travel for this device. So whenever you're doing movements or you're having your collisions, you need to make sure that that arrow is pointing in the direction that it's moving, okay? The other end of this accelerometer is a ordinary USB cable, so that plugs into your computer. And so let's show you how to connect that to Lite. So I'm going to open Lite now. You can see it's this app here. It looks like a green sort of notebook. So I'm going to open that. And so you can see right now it says no sensors found because I don't have the USB end of the accelerometer connected. So I'm going to do that now. Plugged in, give it a sec. There, it's detected it. So you can see that it's detecting acceleration in the bottom left there, but it's moving around a little bit. So this shows you the importance of the idea of calibration. Being a scientist, I think it's important that you understand what calibration is, because all you've done so far is assume that your equipment is working properly. In real life, that's never the case. You, as the experimenter, need to be able to make sure every time you do a trial that it's working correctly. So I'm going to show you how to do this yourself on this software. So right now, I'm not happy with that calibration. It's sitting on the table. It's not accelerating up or down, so there shouldn't be any reading, but it's giving me a reading. So the way that you calibrate is you go up to experiment at the top, you go calibrate, get the accelerometer, and what you hit is calibrate now. And you're going to be asked to put readings and press keep for both of these entries here. And what you're doing is putting in known values. And there's an easy way to have known values here because we know what gravity should be at the surface of the Earth. So the first reading that you're going to do, reading 1, I'm going to hold the accelerometer pointing directly up. I'm using the table edge to help me. So that's pointing vertically. And that should be an acceleration of 9.8, not negative 9.8, 9.8 because it's pointing up. And I'm going to press keep. And now I'm going to turn the accelerometer pointing straight down. Ignore the chocolate stains there. It's pointing directly down, and we know that gravity at the surface of the Earth is negative 9.8 meters per second. So I'm going to hit that, keep it, press OK. And what you'll notice now, it is pointing directly downwards, and the acceleration, you'll notice, it is saying negative 9.8, which is what we expect. I'm going to hold it directly up and down, like this. It's saying 9.8. So those are the entries that we put into the calibration. And so the purpose of all of that is to ensure that when it's not pointing up and down, when it's perfectly flat, like so, focus, it should be pretty close to 0. So you can see the acceleration is only moving between 0 and 0.1. I've successfully calibrated it. You should consider whether your method should include calibration as part of the trial steps or not. That is up to you to decide, but this is just showing you how to make sure that your equipment's working, how to calibrate to ensure accuracy. Hopefully that video helps you out, and I'll see you on the next one.